Okay, guys, before starting the session from Tomasz, he will present serverless orchestration in AWS, but a few words about Tomasz himself. He originated as a software engineer, but quickly realized and fell in love with machine learning and cloud technologies. And right now, his strong software engineering skills find their use in machine learning ops, actually more MLOps, and building and designing serverless applications. So please welcome Tomasz on the stage. And Tomasz, the stage is yours.
My name is Tomasz Dudek. I'm a solution architect working with Chaos Gears, and welcome to serverless orchestration in AWS in terms of machine learning. Moving on with my fast-paced presentation, here's an agenda. What is orchestration? What are my AWS options? And which tool do I pick are the main points. And machine learning projects in general are fully business-oriented. Their task is to create a system to predict X. Business stakeholders don't actually care whether machine learning is actually involved or not, but data scientists would rather get more insights from the data instead of refactoring the code that's mostly research-oriented. We've only recently matured enough to have some production guidelines and some tooling. We've got our own DevOps methodology spin-off machine learning ops. And when the project's finally ready, all we are left with are dozens of interconnected data-related tasks that need to happen in a correct order. So, for example, collecting the data, pre-processing it, choosing an algorithm, finding parameters, deploying the model, and so on. And obviously, we could use some automation of such process to have a reliable production-grade system. So in those terms, orchestration is all about defining what tasks need to happen in what order to achieve some goal. For example, create and train an algorithm. Additionally, we would love to have an SDK or DSL to define the tasks and their mutual dependencies. Defining everything in code has typical infrastructure as code benefits. And lastly, having a system that executes and manages these workflows would be good, so that execution part can be automated and requires no human interaction. Workflow might be simple, like this one. Each of these steps creates a machine or a cluster, or basically performs only a SageMaker API call, but they also might be more complicated. So, for example, we could spin up a Hadoop cluster, spin up hundreds of Spark jobs, then perform some kind of hyperparameter tuning. And why would we orchestrate? Why is the automation necessary? Mostly to save time, because data scientists would spend a day running the jobs manually. The whole process is also error prone, because when we pass data from one task to another, then we could, for example, have picked a wrong file and fed the algorithm with stale old data, the accuracy would have fallen down and so on. So the point is to mitigate human errors. We'd love to bring reproducibility and fasten the experiments we perform. One tweak and pipeline is rerun with different algorithm, for example. Bringing observability, retrying mechanism, monitoring, logs, and so on, so that we have a rock-solid automated pipeline. We'd also like to allow further development of the project to make it maintainable. And when it's defined in code, it can be freely edited, extended, tweaked, and generally speaking, developed. And lastly, there will be no tribal knowledge, no hidden dependencies, no spaghetti code whatsoever. Lastly, why serverless? Well, in machine learning, extremely elastic compute is often a necessity. We use our clusters only for a few hours a week, and most of the time the orchestration system should also stay scaled down to zero, stay dormant. And we'd also love to pay as we go, pay per use. So this is exactly why and when serverless is useful. The orchestration should be a tiny implementation detail, and serverless technologies, generally speaking, have lower TCO than managing the EKS with Airflow or Kubeflow running on them. And the harsh truth is that product owner would rather hire another data scientist, because having one DevOps engineer more to polish the orchestrator brings little value, unfortunately. Moving on to the part 2, let's see what services AWS has to offer. Well, they have 3 of them: AWS Step Functions, Amazon SageMaker Pipelines, as well as CodePipeline. And all in all, they all solve the orchestration problem, but they do it in their own opinionated way. They use different libraries, they have different capabilities, and generally speaking, they all mean different things by saying that they orchestrate. They are widely used in AWS examples, blog posts, articles, solutions library, and so on. But some examples predate the others, and some are straight outdated. For example, Amazon SageMaker Pipeline is a brand new service, and 2 years ago, the line of AWS was that use step functions always. Now they have changed it to perhaps consider using Amazon SageMaker Pipelines, and it will change in a year to come as well, I bet. They are straightforward to pick up, but they aren't easy to replace if you have another system being dependent on them. They can theoretically be used by everyone, but then they have different target audience. One tool was made for data scientists, one tool was made for DevOps, and so on. They natively integrate with other AWS services, but the list of supported AWS services differ from technology to technology. And lastly, they are the backbone of your machine learning system, but then they play different roles in it. You have a model building tool, a model deployment tool, and a Swiss Army knife. Hence this talk. I'd like you to choose wisely. Moving on to the first technology AWS has to offer, AWS Step Functions. What are they? Well, a general purpose orchestration service. The tool is not bound to machine learning. It can orchestrate e-commerce orders or payment services as well. It integrates with dozens of AWS services, and it also has AWS SDK integration. So basically, it can orchestrate anything inside AWS. It holds an internal JSON state of the execution, so the tasks can freely add and remove data to that JSON, and you can pass only some of the data between tasks. It has a GUI builder as well, and it has some advanced parallelization capabilities. So you have while loops, for loops, completely parallel branches, and so on. This is how the GUI builder looks like. We have a Lambda invocation, another Lambda invocation, DynamoDB call, etc. But we could start an EMR cluster, run some jobs, and run SageMaker. You see a lot of native actions on the left, and when the action is not there, then the newest capability is the native SDK integration. So here it is. In the third line, we see that how it actually works. We define that we're using AWS SDK, we're using the S3 service, and we invoke copy object method. We can parameterize the call with data from our state. That's a cool feature. And we can save the call response back to the state. Step functions can be used as an orchestrator of orchestrators. So we can split your workflow into technological or rather business domains and have some parts created by different teams. So for example, you can have data engineers perform the data engineering, then data science team takes over with their SageMaker workflows, and lastly, software engineers build on top of that. If we create contracts, that is, what does given step functions take as an input and what does it output, then this can work really well. There are some hard quotas to watch out for. The maximum execution history limit is 25,000. So basically whatever happens with the workflow and the state, so for example, when task is started, that's an event and the event is persisted and we can only have 25,000 of those events. There are some workarounds. We can split into smaller workflows like shown previously, or we can use continue pattern. The second hard quota is the input size for a task, but it's also a size for the state. 256 kilobytes around is the maximum. And that's usually not enough, especially when dealing with computer vision or NLP problems, but you can always upload your data into S3 and pass only the file reference between tasks. That should be sufficient. And lastly, keep in mind that the orchestrator only orchestrates, so all the hard quotas, that's the service you use underneath, will still apply here. Third, the second service is Amazon SageMaker Pipelines. What is it? Well, it's a data science tailored orchestration service. It's a model building tool. It's a service for data scientists that to automate their model building parts in SageMaker. It integrates natively with SageMaker's offerings like jobs, experiments, projects, and so on. It's included in the usual SageMaker library, and generally speaking, it's natural for a data scientist to use it. It has some offline batch inference capabilities, but then it cannot deploy real-time endpoints. It needs a Lambda call or another pipeline to do that. Keep that in mind. But Lambda is usually not a good idea, especially in a multi-account strategy. What do they look like? Most of those boxes are SageMaker entities, but they can also just perform some API calls or do some if-else branching. There are some hard quotas to watch out for. Maximum number of steps per pipeline is 15. That's not much in more complex workflows. The Lambda step timeout is only 10 minutes instead of usual 15. And lastly, as always, all hard quotas that SageMaker services you use have still apply here. And the soft ones, like the EC2 default EC2 machines limit in SageMaker. Leave that off before you go to production. AWS CodePipeline, the third service, what does it offer? It's a DevOps tailored orchestration tool. It's a CI/CD tool, and your ops team should be delighted because that's basically a typical CI/CD pipeline. It integrates with various DevOps offerings inside AWS, and not only in AWS, but the most important ones for us are code build and CloudFormation. The tool was generally speaking made to automate deploys, but it can automate machine learning deploys, but it can also perform some simple model building because you can spin up and down some EC2 machines. It has some parallelization capabilities, and it's a simple tool to use, generally speaking. This is how they look like. We have a stage to deploy a QA environment. The stage consists of 5 actions, and these actions can invoke Lambdas. They can They can spin up EC2 machines, or they can deploy CloudFormation stacks or Terraform ones. So your stage can be an entire QA environment deployment, or it can be more granular, like, for example, having a pre-processing stage, then a model building stage, deployment stage, and so on, and have dozens of actions within each stage. There are obviously some obstacles. The artifact size limit is only 5 gigs. That's sometimes not enough for large models, but there's a workaround because you can basically just save stuff to S3 yourself and only pass the references between tasks, like in the step functions. But it requires some coding. Code build timeout is 8 hours. That's usually not enough for large models as well. Keep that in mind. You can have only 50 actions in a stage. That's a lot, especially if you have granular split on the stages, so data engineering, model building, stages, and so on. But that's still a hard quota. And there is not too much to choose in the compute types. It's not like you have 200 of EC2 compute types available. You have only like 8 of them, if I recall correctly. Keep that in mind once again. Moving on to the third part, which tool is for me? Well, the general guidance from me is that familiarity is a key. We usually love when technology fits our current stack, but then it's also a double-edged sword. There are limits what can be done with tools we already have, and sometimes pushing them to the limit won't cut it. Sometimes we have to expand, add new technology to the mix, even if that's not really familiar to us. So as a first step, you should define what exactly do you expect from the orchestrator. Some features might sound useful, but in reality, you will never use them. So be sure to exactly define what do you expect and what can be skipped. Extensions are possible because you can always pause the workflow, send a message to SQS and wait until something resumes your execution. And you can always invoke Lambdas, and Lambdas can hold an arbitrary code. So it's possible to extend the functionalities however you need. but they should be limited to the minimum because we'd like to focus on the business and take an orchestrator that has already implemented those features for us. And it requires not too much effort to use, deploy, and maintain. Here's a general capabilities matrix, starting with SageMaker integration, which is available both in step functions and SageMaker pipelines, and it's out of the question in CodePipeline. We have, when it comes to AWS integrations, then SageMaker pipelines only integrate with SageMaker, well, mostly. CodePipeline mostly integrates with DevOps tools, and only step functions allow you to really automate the hell out of AWS. Retrying. Well, CodePipeline allows you to retry on a stage basis. So when you have granular stages and, for example, data engineering one, and then the model building, and model building blows up, then you can fix some task inside the model building, retry the pipeline, and you don't have to perform the data engineering again. That's not the case in step functions. You can specify some retry policy on each of the tasks. That's good. But when they actually blow up, you cannot retry them where the pipeline has blown up. You have to retry everything. So you may have to perform some really heavy computation once again. Exception catching is possible only in step functions, but as always, you have to define what kind of exceptions do you expect it to handle. The complex workflows are possible in step functions mostly. There are some capabilities within CodePipeline, but generally speaking, when the workflow is really complex, then step functions are the only choice, the only tool that can handle them. Cost is low everywhere. That's good to know. They differ in target audience as well. SageMaker pipelines were made for data scientists, step functions for pretty much everyone, and CodePipeline was made to satisfy DevOps engineers. And lastly, when it comes to multi-account capabilities, then CodePipeline is the most friendly one. SageMaker pipelines and step functions, both theoretically speaking, can do that using the event bridge, which is multi-account friendly, but then you'd have to code yourself all that, and there are little tutorials concerning SageMaker pipelines. There are some for step functions, hence the thinking emoji here. Infrastructure as code framework support. The distinction is clear. Step functions, being a tool for everyone, is supported pretty much everywhere, but it's most convenient to work with using CDK or step functions data science SDK, in terms of machine learning at least. SageMaker pipelines, being a tool for a data scientist, is only supported in a data scientist focused library, namely SageMaker SDK. The rest is atrocity and you should never deploy them that way, at least not manually. And CodePipeline, being a tool for DevOps, is supported in typical DevOps tools. Moving on to the step function summary. They are good when your team is large and contains various roles. When you have a lot of data engineers, data scientists, software developers, etc., then they are a good choice. You have a tool to rule all the orchestration. Perhaps you use AWS to its full extent, so you have a lot of other AWS analytics, service, software services, and so on, and step functions integrate with all of them. Perhaps your organization has prior experience in developing step functions because, as I've said, they could have been used elsewhere, somewhere in software development department, for example, and they can speed you up. Perhaps you'd like to orchestrate containers on Fargate or Batch, or you don't use SageMaker though, then you can't use, for example, SageMaker pipelines. And lastly, when the workflow is complex, then step functions are the only choice. Oh, and also perhaps you'd like only one tool, because you can mix SageMaker pipelines with CodePipeline. That's an option as well, but then you'd result in having two tools, and maybe you expected one. They are, however, a bad choice when the team is small and, generally speaking, overwhelmed with SageMaker and AWS already. The learning curve is rather steeper than in the other two. Perhaps you mostly have data scientists and DevOps engineers managing AWS, so step functions seem exotic for both of those teams. And perhaps you want just raw, easy to compute power, and that's when CodePipeline might be better for you than AWS step functions. Second service, Amazon SageMaker Pipelines. That's good when you're SageMaker heavy with not too much other AWS services. If all you need is building model and that's what you expect, then they are fine. When you mostly have data scientists and DevOps engineers managing AWS, then the service is great for your data scientists. You can let them build their model and then deploy them using typical DevOps tools or CodePipeline, for example. You don't mind going all into SageMaker because they integrate greatly with projects and experiments, which are new tools for tracking and managing machine learning projects. They're comparable to MLflow or weights and biases, for example. Perhaps all you want to do is creating a black box for other teams, then the service is great because when your team's job is only to create a model and the rest of the picture is not really your concern, then feel free to use them. The tool is not that great, or actually unusable when you don't use SageMaker. It's only available for SageMaker really. When you use lots of other data and AI services, when you juggle between Glue and SageMaker, for example, then it's not a good idea to have SageMaker pipelines. When the workflow is complex and you use and long and you have many branches and so on, then they are out of the questions. When tasks often fail and have to be retried because, for example, you depend on some periodically dead service, or perhaps you have an aversion to new AWS services because they are quite new on the market. And perhaps you wanted only one tool, and here you'd have two because they only build the model and you need some way to deploy it, and you still have two tools. AWS CodePipeline, most of the time they are not the only tool you will be using. They are good when the workflow is simple and you only have DevOps engineers to handle the production and automation. The service is great when you only wanted to deploy a model for you via CloudFormation, for example, or when all you need is a raw compute power with a simple pipeline to run your Python scripts, and you don't care about SageMaker at all. However, it's not a good idea to use it when you expect it to orchestrate other AWS services or when you wanted a tool for your data scientists. That's not the one. Or maybe you use SageMaker, but you wanted one service and you are using SageMaker pipelines already and expected them to do the deploy, but then you'd have two tools because CodePipeline would be necessary as well. And lastly, a TLDR of entire talk, a decision tree starting with the left branch. Is your workflow complex? If that's a yes and you do use SageMaker, then the question is, do you want your data scientists to keep their tooling or not? If you'd like them to stick inside SageMaker's realm, then let them use SageMaker pipelines, but orchestrate everything else with step functions. But if that's not too exotic for them, then going all into step functions has its benefits of having one tool. On the other hand, when the workflow is not complex and you're not using SageMaker, if all you do is orchestrating containers, then step functions are great. And if all you need is only a handful of EC2 machines to be run every week for an hour or two, then perhaps CodePipeline can be sufficient. On the other hand, with a simple workflow, but with SageMaker, then the question is whether you use a lot of other AWS services or not. If that's a yes, then once again, do you want your data scientists to work only in SageMaker? Once again, that's a yes, then mix SageMaker pipelines with step functions, otherwise go full with step functions. And lastly, with a non-complex workflow inside SageMaker, but without other tools, the question is, how is the model used? If you expected only offline batch predictions, then SageMaker pipelines are great, or maybe it's a black box for other teams. That's also great use case for SageMaker pipelines. But if you expect a real-time inference, then it would be best to use another tool to perform the multi-account perhaps deployment, and that can be CodePipeline. This is exactly what SageMaker projects do, and check them out to see how they deploy free pipelines to exactly do this kind of mixing where you have a model building service and a model deployment service. And I guess that sums it up. Thank you very much for listening to the talk. Hopefully the choice will be easier for you. Reach me out at LinkedIn with any follow-up questions you might have. The link is in the speakers sections of the event page. 25 minutes is quite limiting, to be honest, but I hope you've learned something new. And enjoy the event. Thank you very much once again.
Thank you too much for your presentation. Quite fruitful one, and tons of new information for the audience. I don't know if Tomasz is with us.
Yes, I am, I guess.
Hey. So before moving on, Tomasz, I don't know if you've got any questions on the chat, but in the meantime, I would like to ask you one thing, because you mentioned about the SageMaker, which is pretty, I mean, not the new service in AWS, but it seems to be a quite majored one, with, you know, dozens of new services popping up recently. But is it really a majored service? I mean, ready to be a production grade for developers and data scientists, or not?
Well, that's a great question. Thank you for asking it. And you seem to repeat my exact thoughts that I've had like 2 years ago or so when I reevaluated the SageMaker offerings. And while the platform seemed capable and compelling to use, I've always felt like some parts were actually missing from it. And especially when I compared the overall maturity of the service with more mature services like SQS or S3, then I've always felt like SageMaker was quite young in the AWS ecosystem. But, and here comes an important but, that was a couple years ago. A lot of things have changed, and especially with the recent reInvent 2020 additions, I can finally and confidently say that yes, indeed, we can use SageMaker as our end-to-end data science platform. Because when we look into its offerings, then it's pretty clear that SageMaker satisfies all the requirements from each phase of data science development lifecycle. So, for example, when you start the initial stage where you identify business goals, you explore the data, you perform the exploratory data analysis, then you start using SageMaker Studio, where your data scientists are exploring the data, you start tracking their research with SageMaker experiments and SageMaker projects. Then moving on to the training phase, you have a lot of variety of services there. For example, SageMaker training jobs, SageMaker model debugger, model registry, and so on. And then moving on to the production phase, where you have pipelines that I've just mentioned in my presentation, but not also them. You have SageMaker inference, where you can deploy your models. You have a model monitor, which not only monitors the uptime of the container with your model, but also whether it actually outputs something meaningful or not. And I could go on for hours right now, but generally speaking, yes, the tool is finally ready to be used as of now.
Okay. I mean, I'm curious actually about the future of this particular service, especially in the area of data science. So yeah, I mean the future will show up unpredictable steps. Yes, yeah, and then we've got another question. So I read it loudly, and Tomasz, you can. What Tomasz thought on step functions new SDK integration task type, and did he write his talk after this announcement? So
yes, the talk was made.
The idea.
Yeah, the talk was created basically a few days after the announcement, hence the new word on the slide. But yes, it was after the announcement. And basically, I haven't had a chance to use them directly, but I'm super excited because especially when you orchestrate a lot of, for example, AWS AI services like forecast, personalize, recognition, and so on, very often step functions pipeline consisted of many lambdas that only called the AWS SDK. So you had a Python lambda with like 3 lines of code or so. And now you don't even have to use lambdas for that. So that's like super exciting. And I love that feature, and I'm eager to use it.
Hopefully.
Hopefully.
As always, with new extensions. Okay, Tomasz, if we don't have any questions, once again, I'm really glad that you joined the community, of Serverless Days, and you put the effort to present us a little bit a piece of the world from a data scientist area. So once again, thank you very much. Good to see you, man. Take care. And we are guys moving on.